Black Friday is around the corner and we are doing 50% off all of our crested, gargle, and blue tongue skinks. This is the biggest Black Friday yet, so don't miss out. If you want to get access to early discount codes, make sure you go to our homepage and sign up for the email notifications. Now, enjoy the podcast. All right, guys, this has been a long time coming. I am here with Nicoletta and Dan, and they have done some amazing research in regards to all the soft scales and everything. I know these two are obsessed with soft scales, so I'm, here to pick their brain on this new research they have done, and I'm super excited. So before anything, I just want you guys to introduce yourselves and just kind of like tell us how long you've been working with soft scales. Nicoletta?
I was changing my name again. There, I fixed it. Sorry. Nicoletta, Juliana's Geckos. Yes, I'm obsessed with soft scale geckos. Specifically working with the gene since the end of 2019 as far as breeding it specifically in my collection. And yeah, so it's like, what, 4 years or so?
Yeah.
I think. Yeah. I loved it from day one, and that's what got me into breeding and this hobby, and I will love it forever, I'm pretty sure.
A love-hate relationship, huh?
I mean, right now, yes, but not forever.
Yeah. What about you, Dan?
Yeah, so I've collected crested geckos for quite a while, but once the soft scale gene started coming out, it really brought me back into the hobby. It was kind of the first thing that I saw that caught my eye, and you could look at the animal and be like, something going on there, so
Yeah.
I dove back in and started collecting again big time like 5-6 years ago. But yeah, like I said, I used to collect like back early 2000s, and kind of came and went a little bit in the meantime.
Yeah, in the
Dan
very
and I
beginning.
met. Dan and I
Yeah.
met over a gecko I bought that he wanted, and that's how we got to know each other. Is he messaged me about a soft scale that I bought that he was like, "Wait, I wanted that," and it was only online for 5 minutes. I bet you got it.
I didn't think anybody was like as crazy as I was,
Yeah, I think you met me.
Yeah.
We were battling it out for all the cool stuff.
Yeah, I mean, you guys have mounted a really large collection of soft scales, and that's how it is. Like in the beginning, right? That when something brand new comes out, everybody's like chomping at the bit to get like the best of the best. But yeah, I'm excited about this because soft scales for the longest time have been like a morph or a trait that I've looked at, and I've always it's hard for me to promote or sell something as soft scale because I've always thought is this like soft scale? I can't really tell. Or some geckos that look soft scale are not, and some geckos that are don't look like or whatever. So I'm excited about this. But just for the basics, for you guys that are watching that don't necessarily know what a soft scale is, I want you guys, both of you, to describe, to give us a simple definition of what a soft scale crested gecko is.
Yeah, I guess like, is it what we thought it was or what we found from the study?
Well,
It's changed throughout the years for me, for sure. I went from thinking like, these soft scales were brighter or, more colorful animals, cleaner looking. But, we're at a point now after like really looking at these closely where it's, the genetic is changing the scale structure, spreading them out a little further. And it does, make the animals look really cool, to put it simply.
So what exactly is it doing to the scales?
Yeah, so on average, it's basically like spreading them out, the distance in between the primary scales, as we call them. It's about 20%. I think we came to that measurement, like that far apart, than your average, your normal crested geckos, or
Yeah.
Yeah. So I mean, in the
too, so.
yeah, the basic definition is that the soft scale gene is taking the primary scales, which is those big scales you can see from a naked eye on the gecko, and they're farther apart. And what we found in our study is that the secondary scales, or that spacing between the scales, is actually separating or more prolific, which is either causing the separation. We don't know what came first, the chicken or the egg, right? But we know that there is more spacing between the scales, and that is proven in our study. And also, we are seeing that there is a small variation in the size with the soft scale, or the homozygous soft scale of the actual scale is a little bit smaller. So those primary scales are farther apart. The spacing between is splitting, separating, or more prolific. And then the actual scale size itself is a little bit smaller than that of a normal crested gecko.
Gotcha. So I just want to, touch on the history of them real quick for those of you guys that maybe don't know the history. But basically, AC Reptiles, Anthony Caponetto, came across this gene that he coined soft scales, and he basically said that when he noticed that these geckos had like a matte color, or they were just like brighter. He said that the first couple soft scales were having like a ring around their eye, and he according to him, the soft scale is an incomplete dominant, which would mean that if you breed one soft scale to a normal gecko, about 50% will come out soft scale and 50% will come out normals. And if you breed, a super soft scale to a normal gecko, all of them will come out soft scale, right? So that's what he had said. And here, originally he was the one who started that. But one of the questions that I got on the Instagram page when I asked, what people wanted to know about soft scale was, how was soft scale discovered if soft scale animals don't visually display the gene? Now,
yes,
go ahead.
really quick though, to add, David, Anthony Caponetto also mentioned that he noticed that the scales were farther apart. So that was something that he mentioned, and still mentions on his website, that he noted. So not only did he say that he saw this mat-like appearance in color, he felt the geckos, they seemed smoother. He may have seen this ring around the eye. He also mentioned that the scales were farther apart.
And also the scales seemed to be flatter.
He did not say that. He said smaller, but that made them appear flatter.
I mean, there was talk about them being softer. I know the feel was a big part of it.
The feel was denoted. And then there was another post put out by Little Monsters in 2020 that actually posted pictures of the scales. And in that specific post mentioned the spacing between the scales, and the pictures that were posted in that post when they defined the gene as incomplete dominant. They talked about the spacing between the scales and the pictures being taken on the top of the head between the widest parts of the crest when they defined the gene on that post as well. So there was about 5 or 6 things between those two areas, kind of in the history of the gene and what we were defining it as, that denoted what
I was curious about was when, how was it discovered? Back to that question. I mean, was the super form found, and then it said and then the het forms show, or was soft scale being talked about before the actual super forms were found too? I mean, or was it all just kind of released at the same time? And it's like I might have noticed the difference in these. But and that's huge, because we've done a lot of thinking about this look that the soft scales have, and I don't know if we want to dive right into that, but it's
just before that, I want to say something, that just like with any other recessive mutation like the axanthics and the albinos and other reptiles and everything else, nobody really knows that they have heterozygous soft scales or albino or axanthic until you prove out the visual, the homozygous version. So maybe AC saw, you know, a homozygous soft scale and said, oh, wait, there's definitely something going on here.
Yeah.
And maybe down the line, he started breeding it out and came up to those conclusions, right?
Mm-hmm.
But, you know, that's
neither
here or there. At the end of the day,
I know.
we're here to talk about what you guys have done, the research that you guys have done, because I'm really, really interested in everything that I have read from your research paper and what you have on your website, Nicoletta. So I'll let you guys kind of explain what the process was and what you found out.
Cool. Well, I think I'll start with just like our process of how we kind of got to where we're at, and then Dan can touch on the color stuff right into it. But basically, for Dan and I both, we were talking about soft scales every single day, and you know, it came to a point where we were struggling with some of the results we were seeing within our projects, not necessarily aligning with incomplete dominance, and struggling because we are constantly getting questions from people. Now, mind you, like I was so passionate about the gene. I know Dan was so passionate about the gene, and people knew that. I mean, everywhere I went, I was talking about the soft scale gene. Dan, same thing. So when people started asking questions about soft scale, I'm giving them the answer that I heard, not necessarily the answer I believed in, not necessarily the answer that I thought to be true, but instead it's lineage, right? I bought these two supers from this place. I bred them together. So this is a super. You know, I didn't have confidence in what I was telling people. And then the question that came up the most that was really, really challenging to answer was like, is this a soft scale? How do I tell if I have a soft scale? And it's like that question to somebody who's so passionate about the genetic as I am or Dan is, like, to not feel like you have an actual answer that is scientific and truthful when you're offering information to somebody about something you're like supposed to be an expert in is very hard. I mean, I struggled a lot with it and Dan struggled a lot with it. And we constantly were going back and forth like, how can we not answer this question? And we have these animals in our collection and we can't answer it confidently. And not that we felt like we were lying, but at the same time, it was like, are we making this up? You know, it was just this constant battle back and forth trying to answer that question. And it wasn't even really for us like the homozygous animal. It was the heterozygous animal that was the biggest problem, you know, because the visual differences were so inconsistent that it was almost just a toss up. So that's what led us into this, like, we need to back up a little bit. We need to start doing some of our own research. And that's kind of what landed us where we were in the beginning process of our study. Just to give you a little bit of background. I don't know, Dan, if you want to add a little bit to that, but
yeah, I mean,
that's kind of our why, truly.
Yeah, and I touched on the same point. You know, I'd be at shows and you know, you invest in a certain genetic and you know, you want to label it as something. So I have animals on my table that are soft scales everywhere, you know, and I'm trying to explain to just like everyday people, like what's the difference here, you know, and it's kind of like what Nicoletta said, you know, you're saying what you've heard, you know, like, oh, well, they're brighter and, you know, they're cleaner looking, you know, matte, I guess, you know, some people say, but it just didn't seem right, you know, from what I was seeing, you know, because I've like, you know, bred soft scale into a lot of different lines and you know the variations all over the place, just like we would have with normal crested geckos. So I wasn't seeing, you know, this obvious like, oh, that's, you know, a hat, and so that's when it started to raise questions in my mind. You know?
And I just want to say that I never saw that either. I definitely have seen some animals that, you know, I look at it and I'm like, oh, that's clearly a soft scale, right? Because you'll have like that little patch of like, you know, on top of the head or like even on the snout. And there's this look that we all like say, oh, okay, yeah, that's soft scale. But when it comes down to my collection, I have soft scales because I've gotten them directly from AC. And I can never tell. I can never tell with my lines when I bred them to my stuff. Is this a soft scale? Is this a soft scale? Is this, you know, is this? I never
I mean,
bred for super softs, but yeah, I mean, it's, I think if somebody with as much experience as we do couldn't really tell them apart,
Mm-hmm.
and we're starting to notice that it's a little bit too hard to distinguish,
Yeah.
then yeah, there's, I understand 100% what you're saying.
Yeah.
Well,
I mean,
what
yeah, supers are, in my mind, easy,
Yeah.
and that's kind of what I would default to at the shows. I'd be like, well, yeah, if you get a super, like that's what you're really trying to make here. And I mean, that works for a recessive genetic too, but it's just, when we're talking about seeing something in these hets, that's just where it was kind of lacking.
Well, and
Right.
I kind of want to talk through, because like I have a science background and Dan has a science background. And when we started, when we talk through genetics, and I mean, obviously reptiles are a little bit different than humans and there's a little bit more at play. But when we talk about incomplete dominance, right? Like it's not confusing. It's actually simple. So if you look at something like a lily white, that's an incomplete dominant genetic. And you see the visual heterozygous animal, which is the lily, the ones that we all, work with, right? That's our visual het. You breed those two animals together, you get your super. In that case, it's a lethal gene. We can't actually have the supers. But you look at a lily white and visually, like that is a lily white and it is distinguishable against the rest of the geckos. Now, there might be expressions that you see in the lily white with color, pattern, different traits being stacked, polygenics where you see bloodlines of animals, but you still have your visual heterozygous lily white that is defined by something we can see throughout the entire spectrum of the crested geckos, right?
Yeah, no
When
matter
you
what you bring it to.
No matter
Right.
what. Doesn't matter if you pair it to an exanthic. Doesn't matter if you pair it to a triple X animal. Doesn't matter. Like those expressions and those traits that are stacked, we call, in my mind, I call that polygenics and bloodlines that carry on specific traits and expressions. But what we see is a lily white. And that is the visual heterozygous for that incomplete dominant gene mutation. When we look at soft scale, and you look at your homozygous, which in this case we call the super soft scale, right? Which we'll get into this a little bit more. But what we see is a visual trait where the scales are altered. We see this in all the homozygous animals, and it is very, very simple. It is not hard to see. It is very clear, and it is potentially changing the colors and all the things, we talk about in the homozygous animal. When we look at the heterozygous animal, to the homozygous soft scale, there is no consistent visual trait that can be seen amongst your heterozygous animals that is different from your normal animals to really discern and denote that a heterozygous exists visually. So when you start to talk about all the other animals or all the other traits that go along with these animals, and we're looking at the scales, there is not enough for us to say this is a visual heterozygous soft scale based off of the homozygous soft scale change that we're seeing. And that's what was so hard for me. I'm like, incomplete dominance it's not hard. It's very simple actually. And the lily white is a great way to see that. We can look at different ball python morphs and genes and things like that too, that show the exact same thing. So when I started off with soft scales in Dan too, I'm looking at these soft scales, which is going to be your visual het, like your lily white. And I thought I saw something. Like this is actually like, I feel like I trained myself to see these traits, these bloodline traits that were stacked into these animals, because of so many times over, I said to myself, this is a soft scale. This is a soft scale. This is a soft scale. Some of these things we're talking about, color, feel, look of the animal, right? But when you get down to the nitty gritty, like incomplete dominance it's not confusing. It's not like, is this het? Is it not? Is this lily? Is it not? It's very simple, right?
Yeah. So I agree. But there's going to be people that say, well, I could see it very clearly. My heterozygous soft scales have this look. They're matte, or they're cleaner, or they're, X. So what is going on there that that people, what are people seeing? Is
Yeah.
it these traits or these, polygenics that have been developed parallel to the soft scale because most of them come from one person's
Mhm.
collection? Is it, is it altering the color in a single gene? What is it? What's happening?
Yeah. So, I mean, I think it's kind of funny. Like, for a while I was saying, they're brighter, and then matte, matte means dull, right? So I don't know if like matte people are using it to say like the color is kind of consistent along their laterals more, or, I mean, because it started off by saying these animals are brighter, and then now it's kind of
Yeah.
changed a little bit to say they're duller. But yeah, like what you said about the polygenics and the specific lines that they come from. I mean, I think like you don't look at a high patterned animal like something like a triple X and be like, oh, that looks like a soft skin, because it's just like not the characteristics that we see in, like you'll see a full pinstriped animal. It'll have like quad stripe or walls or whatever, and then it's very clean above that area. But like all that really means is, there's not the tigering of the animal has been like pushed all the way down. So
Right.
basically you go from like one end of the spectrum being your triple X animals to, and I would argue that like the other end of the spectrum is these soft scales, because like there is none of that background patterning, but you can put it right back into those animals. And that's another, thing that I did is I paired high pattern animals to super softs, and then you get something in between, and then one more generation, it's like this doesn't have your classic look anymore. You do,
Right.
but the genetics still in it.
Yeah.
So that told me a lot when I started seeing that.
Gotcha. Yeah, makes complete sense. I think it's gonna be hard for people to accept that in the beginning, and they got to be honest with themselves and say, okay, you know, if am I really seeing this, or is it just like something that's been programmed into me? And
It was a hard pill to swallow. I'm telling you, like,
yeah,
because
I
I
had one.
thought I
I had
had,
one morning. One morning, I called Dan. After my youngest son, he's just like, "Mom, like you're not looking at this right. You're missing something. You're missing something, Mom." And I called Dan and I said, "Dan," and this is the honest to God truth because I'm a very transparent, real person, and I have nothing to hide in any of this. I said, "Look," I said, "my eyes are trained to see something, and I know that." I said,
yeah,
I have to completely untrain my eyes from what I know to be soft scale because right now our results are not aligning with what I think I see. And I said, I have to unwind. I have to start looking at my collection entirely differently because I do have animals that don't have soft scale lines. And I do have animals that have soft scale lines. I have animals with non-soft scale lineage that have badass color, badass, what I would say
clean.
like, yeah, exactly. They're clean animals. I mean, look at Emily Burke's animals. I mean, it doesn't get much cleaner than that. Okay. Now, so for me, it truly came down to like erasing this placebo effect or the stereotype that I had on these animals, to be completely honest, based off of what I was sold. Okay. And that's not to mean any harm, no foul to anybody, but that's how I had trained my eyes to see something. Now,
Yeah,
for me, because we were doing something that was so abstract, it was really important for us to do that because without allowing ourselves to have less opinions on the animals, we couldn't actually break through to really see what was going on. So, speaking to other people who are seeing these things or saying, I have this heterozygous animal that I can see that that it's a het. My question to you or to them would be, A, do you see this in every single het you produce? That's my first question. Second question, can you describe to me what you see? Okay.
Yeah.
it's brighter.
That's my next question. Right. Is it though? Because is it brighter in every animal? Is it soft? Is it a feeling? Is it multiple things that you're seeing in one? Or does one animal have the soft feeling, the other animal has the bright color? You know what I
Yeah,
mean? So you really have to ask yourself these questions as you're walking through it. Because for me, that was very challenging. And to be completely honest, I wanted to see a heterozygous soft scale so badly because that would
Yeah.
mean that all of this, you know, didn't have to continue on. Like it would make it so much easier.
I think that's an important point to make. You know, like we didn't set out to try and
Prove is
disprove
wrong.
it's genetic. You know,
Right.
we were looking for something that, you know, we could confirm from like our het pairings, you know, and to help us, you know, and like total believers. But then, yeah, it was like we even got to a point where like we must, you know, it just must not be what we think it is. It's not the scale spacing because like,
Right.
you know, some of them have it, but then like when we just like no, it's got to be that. Let's look at it differently. Let's imagine there is no, you know, difference, and then, you know, it all started to click. And then yeah, after we, you know, got the results and kind of sat with it, it's like been this unwinding of like what, yeah, like what Nicoletta was saying with like I've been trained to see this thing in these geckos.
Yeah.
And I mean, I have some geckos that like I would have put money. Well, I did put money on it, but I mean, like I would say this is a super, you know, like no doubt.
Yeah.
But you know, it doesn't have the spacing, so
Yeah.
and it goes vice versa. It's like, okay, this animal, I found, you know, another one yesterday. I showed Nicoletta. I'm like, look at this, you know, this is another homozygous, and it's like, what? So you know, and it, one thing that comes up is like people don't have microscopes. You know, I'm going around with just a little loop, and
No, I
it's
did it with
obvious.
the iPhone camera.
Yeah, so
But the
you
new
can
iPhone,
real easy if it's there.
yeah. No, and that's a good point because yeah, well, when I was talking to Nicoletta about this and I read you guys' paper, and now naturally I'm like, all right, I'm gonna go look at my geckos. So I
Yeah.
put the, you know, with the iPhone, if you go to on the macro setting and then you zoom in ×3, you could see the scales very
Really?
clearly. You could see.
Is that what the pictures were that you posted the other day?
Yeah, those are from my iPhone.
Really?
Yeah.
Wow.
So I have a group of soft scale animals that came from AC that I have 3 girls, right? 2 of them, I'm like, these are super soft scales, no doubt about it. And this one girl, I'm like, this one maybe is a heterozygous. It's a normal soft scale. So I'm looking at them, and turns out the 2 that I thought were super are not super. They're heterozygous. If I have faith in AC, which I do, and the one that I thought was heterozygous is actually the super soft scale or the homozygous version of the soft scale. So I'm like, wait, whoa. I thought the look of the soft scale was of the super soft was supposed to look like this, but it's actually like it flipped on reverse for me.
Yeah, you know, like I find they're kind of bumpy. You know, like some of the ones I'm looking at, like they have that appearance. It's not like when you say soft scale, it's not what comes to mind with some of them, but
yeah,
there's a
and
combination.
You know. It's a hard name to, especially to explain to people, because you give somebody a crested gecko, especially if they don't have much experience, and you give this is super soft, this is soft, this is a normal. They all feel soft. They're not going to be able to tell the difference between all of them. But so going back to your guys' research, how many geckos did you guys sample? Like, what was the pool sample of the geckos you looked at? How many super soft and how many soft, heterozygous and homozygous?
Really quick before we move on from, because I wanted to add one more thing, David, that I think is really important to this talk of color before we move on from that. And just like the point to in kind of unwrapping this is like neither Dan and I set out to like have anybody redefine the genetic. You know, it wasn't like our goal to be like, oh, everyone needs to start calling it recessive or, you know, incomplete dominant isn't a thing or whatever it is. But when we talk about the actual genetic itself and how we determine and denote the homozygous animal, which is the scale spacing, because there's so much variability in the color, depending on the lines that are bred into it, that people may or may not be seeing in the heterozygous animal isn't enough to now redefine the het by a color when we're talking about the homozygous having scale spacing. And I think it's important for people to also understand that when you're defining a gene, We can't define the homozygous and then define the heterozygous by something else. It's not really how it works. Not to say that those other things aren't at play and that the color isn't important and then, you know, things like that. But adding to the color thing and what you said about finding stuff in your collection, since this study's been out, there's been other big breeders who have been working with geckos for a very long time who also, like you, started looking at their collections. And I'm not going to say any names because that's irrelevant and it's, you know, their information that I've been working through with them. But I will tell you, they've unwinded some things, and some of these animals that are unbelievable animals from other lines that look absolutely nothing like Anthony Caponetto's animals where these lines originated from, we're pulling out soft scales in other looks. That's kind of the idea of it. But what's cool is these other animals, their 12, 13-year-old stock comes from Anthony Caponetto. So it's still tracing back to the same place. It's just that they took it and went a different direction and had no idea that that could have been the key that unlocked these animals that they've produced that not a lot of people have been able to replicate. So there is more looks out there in the homozygous than even anybody knows about right now, you know? So I think it's really cool. And I think that color is part of the gene. I'm, you know, neither Dan or I are arguing that that's not a huge part of the genetic. It's just not enough to define the genetic.
I would agree with homozygous, I would say for sure. But with the hets, I think that I mean, you'd have to really show me something that makes sense because I have hets of like every color under the rainbow. And if there's a color change, it's like, what is it? You know, I mean, like, just to play devil's advocate with what you said about the color change in the hets, Nicoletta, and like cappuccino, I know is going to be used as an example in this. So like, well, that one changes the color pretty drastically. Like, I mean, it's very obvious. You know, it does quite a color change to the head animals, and then the super animals. Obviously, there's a structural change in that one, but with the, you know, there has to be basically a difference between a wild type and then the head animals if you had like the same pairing. Which in soft scale hets, they're just, I mean, there isn't. You know, it's like, has somebody, do you see something? Because, you know, they can't be chalked up to pattern or you know, the lines that it comes from, basically.
Okay,
for sure.
Yeah, no, it's a good point, guys. But going back to the previous question, so what was the pool sample of your research? How many
Hold on,
soft
I was trying to pull up my my spreadsheet here.
paper? Go ahead, go for it. You could do it.
Okay, what was your first question?
So how many soft scales did you guys look at, and how many, let's call them heads and homos? How many head soft scales and homo soft scales did you guys look at?
Okay, so kind of like unwinding the actual study and research itself. We actually had to start with all the homozygous animals because the heterozygous, there was nothing really for us to go off of initially, right? So anything we thought was het that wasn't proven out as het, we kind of had to like just toss. Like we couldn't really,
because you know weren't seeing any difference between normal scales and het soft scale scales.
Exactly. So we had to start with our homozygous animals, which I believe, I'm trying to pull up this spreadsheet here, but in Dan's collection, he had 11 for sure homozygous breeders. And I had, sorry for him, a little bit more. And then I had 21 that we were using. Yeah, he thought he had more. And I had 21.
Okay,
so
21.
Yes. And then, so that was what we had to use for our breeding stock and our lines as far as calculating through. Thankfully, I'm a hoarder. So we had quite a few offspring, and same with Dan too. Actually, we had a decent amount from him. The only part that was hard is that, you know, I had a huge soft scale lily I still have it, a huge soft scale lily project going on, and Dan had some other things he was breeding his soft scales into. So what we thought would start out as this massive group of animals we could use, kind of we had to like go like this to make sure our results were as accurate as possible. So we eliminated phantoms, we eliminated lilies, because, you know, we had to just get back to the bare bones of the gene. We couldn't add in all these other factors, if that makes sense.
Yeah, it makes sense.
But yeah, so out of that, I know I got lucky and I had a pairing 3 years ago. There was 2 homos that I have.
That will never not be funny to me. I'm sorry.
But they're grown up now. So, and you know, the year after that, I think there was 3 pairings, homo to homo, and then you know, so we had like some of those pairing. That was what I was worried about, was like not like, you know, once we started seeing you know, that some of the ones we suspected as supers weren't, that we weren't going to have those pairings to confirm like all offspring, but we had plenty of those too.
So out of those pairings that were both homozygous animals, all of the offspring that you guys kept, that you have, are homozygous, and you could see the, you know, the scale separation when you look under the microscope.
Yep. Now it takes a lot longer than you would think, though. I mean, that's part of the thing we're trying to dial in now, is like at what size can you see it on the geckos?
Yeah, that was
that's
one
the
of our
worst part. Yeah, that's the worst
like
part
20
about it.
grams, I mean, I'd say is like kind of safe to start looking, but like not before that, you know.
So I'm sorry, how long?
I'd say 20 grams to start looking. Like I've never seen it earlier than that.
Now, do you think if you got maybe like a more powerful microscope, you would be able to see it, or you just think as the gecko grows, the scales are separating?
I think that it must be something that happens towards adulthood, where, you know, and even AC touched on this, like when he wrote about the gene, he's like, once they reach, you know, this 15 to 20 grams, it was like, whoa, you know, something seems to happen.
Yeah.
So it kind of confirms that. I don't know. I mean, maybe we spent quite a chunk already on some microscopes, so somebody else can do that. But
Yeah. So around 20 grams. And about how many offspring from that homozygous to homozygous pair or pairs did you guys have? Like how many did you guys look at?
you'd have to
hold on. I'm looking. Just give me a second. A lot.
yeah, I'd say like probably 50 or 60. You know.
Yeah, we have so many spreadsheets. It's disturbing. Should see our Google Drive.
Okay, well, that
we didn't do any measuring on those. It's just like basically confirming. And I mean, I'm still going through stuff and like confirming once they reach a certain size. I haven't seen anything that.
Sorry. Okay, I found it. So we had out of the homozygous pairings at that 25, because we didn't put anything under 25. We waited till 25 grams to even start looking. But in our actual study, like our the research that we did where we did our measurements and stuff, we didn't do any measurements on anything under 35 grams. So all of our measurements were 35 and above. So out of those pairings, confirmed homozygous offspring animals, we have 59. And out of that, we were able to sample 26 homozygous offspring after that 35 grams for our study. And then it's even more than that for the heterozygous samples. So we were able to get 37 heterozygous animals after that 35 gram mark to also take scale samplings from. And now this is combined between the two of us. So.
And that's between the two of you. And from pairings that are homozygous animals to normal animals, why was the pool sample on that?
Well, as far as heads go, you mean? That's the only heads we used. We only used homozygous
pair.
Homozygous to a normal pairing, just because we didn't want to have any extra information that was ambiguous based off of potentially throwing in a homozygous in there, if that makes sense.
And what's a
measurements? Sorry, say that again.
And what's an estimate of how many animals that is?
For the heterozygous sampling that we did with the measurements, it was 37.
Yeah, 37. And normal animals?
Normal animals, it was 29, but that was just because I was sick and tired of looking at them.
So, okay, so what I was trying to get at is that out of those 37 heterozygous soft scales and those 29 normal geckos, they all the data matched. They all the scales were, you know, pretty much the same.
So yeah, that was the biggest pain. But it turned out to be so close, which was really cool. I mean, when you're doing something like that, it might vary like a little bit from one gecko to another. If you just have one, but we you know got a lot of data, and like it was so clear that like there was just very little difference between normal and het, and then the homos just jumped up. You know, it's like wow, okay.
So, but this might be a good time to talk about the rest of the scales on the body, because I think there was a lot of people who asked, you know, did they look at the scales? Yeah, did they look at the scales on the dorsal? Did they look at the scales on the laterals? And yes, we 1000% did. We looked at it, you know, as much as we could on the entire body. But basically, where we started was when we identified the homozygous animals, we went back to the picture that was posted on is it Little or Lil Monsters?
Lil, like Lil Wayne.
Lil Monsters page back in 2020, because when we started looking at scales after color, we looked at color first. That was the first thing we looked at. We're like, there's nothing here. There's nothing here we can actually really use. So we went back to that post in 2000, you know, that was posted in 2020. And I said, well, you know, Anthony Caponetto mentions the scale spacing. Little Monsters mentions the scale spacing. Let's look at these pictures they took. So we looked at the couple of pictures that were on that post, and it said in that post specifically, these pictures were taken on the animal's head between the widest part of the crests, and that is where we're seeing the scale spacing. And that was the first time there was some kind of concrete information that I could find about the actual scale spacing. So when we started our look at the scales for the homozygous animals, we started there because we wanted to match the information that was already out there. We didn't want to just come up with something on our own to define the soft scale animal or the homozygous in the animal. So that's when we started looking at that. So when we looked at this, you know, the scale spacing on the head where we started to identify these homozygous animals, we're like, okay, we can see it. We can see what they're talking about. We can see the scale, these primary scales are farther apart. That was with our first microscope. And then I'm like, but Dan, we got to see closer because we don't really know what's going on between the scales. And like, wouldn't it be cool to have some kind of like, why are the scales farther apart? Whether it's there or not, I don't know. So then we invested in a much nicer microscope and started looking at the homozygous animals again. And we're like, holy crap, these scales are either splitting or they're more prolific. There's more of these secondary scales coming in between these primary scales. It's pulling the scales apart. And we're like, holy crap.
Really
we are like, this is really cool. Like, oh my gosh. And then, we started looking at the dorsal and we started looking at the laterals, and the spacing that you see with the splitting or the proliferation of the secondary scales, it's on the entire body. It starts on the head, but then it carries through. And we're like, okay, like this is it. This is our homozygous animal. So now we got to go look at the rest, right? So as we started looking at these heterozygous animals and the normals in all different patterns, all different things, we're looking at this, and some of the hets had a little bit of spacing in their dorsal and spacing in their laterals. Some of the hets had no spacing in the dorsal with very little spacing in the laterals. Some of these normals had spacing in both laterals and dorsals, none of which of them had any spacing starting on their head. So when we started looking at the scales on the body, what happened was that information became pretty irrelevant and ambiguous and kind of a moot point when trying to recognize the heterozygous animal. Had we seen this homozygous animal and then all of the hets, right? All of these 37 hets we were looking at had spacing on their dorsals and laterals, and then the normals just had it on their laterals. I mean, holy crap, that would have been incomplete dominant. It would have been like, boom, 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 here we go. But that's not what happened. Instead, the dorsal and the lateral spacing was very inconsistent in both hets and normal animals. So unfortunately, that information became not necessarily helpful to us in identifying the heterozygous soft scale.
Now, when you guys are looking at the dorsal and the laterals, and you say you see some spacing in normals and in heterozygous soft scales, are you guys seeing those secondary split scales in there, or just the spacing?
Not as
Well,
no.
I mean, you see on the laterals, you can see. I mean, it's there.
So
In both.
what I feel like with you when you look at the lateral and the dorsal scales compared to the head scale, so like when you start looking at all these scales under a microscope all the time, you start to notice these little nuances, right? And so the lateral spacing and the dorsal spacing, even on most crested geckos, if not all that I've looked at, have more spacing on those compared to the head, right? So we look at a normal, right? The smallest spacing you see is on the head. If you start looking at the laterals and the dorsals, you're going to see a little bit of spacing in between the scales on those animals in both places compared to that of their head. So what's interesting is like when you see the homozygous animal, that crazy spacing with the massive, this is where maybe David, we can insert another picture to kind of show this example. And Dan and I can send that to you. But basically, when you look at the homozygous animal, laterals and dorsal compared to both the het and the normals, it's so much different. Like it is so glaring in your face. But then when you start to sample in those spots on the normals and the hets, there's all kinds of inconsistencies in both. There's nothing consistent that can give us that straight across answer to say, oh, the scales look like this in the heterozygous animal. Like what, we don't have that.
I mean, and it's not saying like that, like, you can analyze every part of the animal very closely if you want to. Like the toe pads, and like we tried to find stuff. Like I was looking at like the vent area where you check for pores, because I was like, maybe, maybe there's something there, just some sort of easy marker. But obviously we didn't run like such extensive research on like any of the other areas of the gecko, but it turns out that this spot on the head like really works. I don't know where it first came from, but for this genetic at least, it's like it's a really good marker. It's easy to check, and it seems to be the one spot that stays true.
But I mean, but that does carry on to the body. It's not like in these homozygous animals, you just see it on the head and then it goes away in the rest of the body. Right. It's carried through all the way. And I talked a lot to a good friend of mine who's very, very well versed in reptile genetics. It's Kevin McCurley. I talked to him at length about trying to wrap my head around some of these things that I was really struggling with. And it kept coming back to the fact that the homozygous animal is very, very obvious when you're looking at the scales. So when we're trying to define the gene and look at a visual characteristic or a phenotype of the heterozygous animal to define it, we have to have something that is consistent in all heterozygous animals, not something that's there some of the time, depending on the pattern, depending on the color, depending on whatever it is. Like we have to have and Kevin will say in the ball python world that it has to be there 100% of the time. Like in the ball python world, in a heterozygous animal, or that you're going to say is incomplete dominant, that phenotype has to be there 100% of the time. Otherwise, you can't denote it as an incomplete dominant gene. So, we talked about this at length because I know there's a lot of information out there that, crested geckos have this going on and this going on. So we can stack all these phenotypes on top of each other. So now we can characterize a gene by 6 different things because of that reason. And, I struggled with that because the homozygous is so clear and it's so obvious. Like I could not wrap my head around having 5 other things to define a gene that seems like there's one thing that defines it. So then when we backtrack out of that to the heterozygous animal or to find a phenotype for incomplete dominance, it can't be so confusing. It's just not how genetics works for me. So, you know, when we set out to do this, it's like, I want my consumer. Now, mind you, like, I can't speak for every other breeder working with the soft scale gene. I can't. I can speak for myself. And for me, I want my consumer who comes to me, Nicoletta, Juliana's Geckos, and says, hey, I want soft scale in my projects. Like, how do I do that efficiently? And how can I use this gene to amplify whatever it is that I'm doing? Well, if I have this answer of, you know, well, you have to watch for this, this, and this to pick your soft scales, and it's slowing down the process. When I look at it as a recessive genetic based off of our findings, it's very simple. You can define your homozygous right now. Like, here it is. It's that simple. Now, that's your homozygous animal. If we want to talk about how to breed that back into your collection, if you do that with recessive means, you're going to get there more quickly than if you think it's incomplete dominant and you start piecing together possible soft scales based off of how they look or how they feel, and maybe bringing those into your collection this way. It's very confusing, and it doesn't need to be. So for me, I'd rather be able to help have my consumers have a tangible way to identify the homozygous, how they want to recognize the gene, whether they want to think it's incomplete dominant or recessive. It's totally up to them, and it's totally up to other breeders how they want to present it. But based off of the information that Dan and I have collectively come up with based on actual proof and research about what's happening in the scales, is that this gene mutation, soft scale, is way more aligned with a recessive gene mutation and how you can prove it out and bring it into your collection. And that's going to make things happen far more efficiently and far, far better. So, you know, that's what it comes down to. And, you know, genetics don't have to be confusing.
But one really cool thing that's come out of this is like being able to confirm, you know, you got like, and people actually checking, you know, it's like, I think that it's going to progress this gene a lot faster now that you can just look with a loop and be like, okay, this is it, you know, and it's not always what you think. So if you're taking things for granted and going off of lineage, or I would just, you know, take a step back and make sure you're working with what you think you are.
I agree. I think ultimately it's, you know, somebody had to do it, and I think we trusted, you know, I mean, of course, AC's a pioneer. He's a person a lot of us look up to because of all the work he's done. But without that, you know, that evidence, it's hard to say, you know, that what you're looking at is actually there for, you know, for especially for his
being able to quantify it. I mean, if you know, if it was like, okay, there's like a, you know, a 3% difference even in these, you know, with the scale spacing, it would have been something, but there, you know, it's nothing.
Have you guys noticed any spacing between the pinstripes or the eyelashes? I know I asked Nicoletta this earlier, but what about you, Dan? Have you noticed anything like that in the homozygous version and the heterozygous? Well, obviously, well, not the heterozygous, but the homozygous.
Not the het, or else we'd have to tear up that paper. But no, in the homozygous, you know, one thing that's really cool with it is, and you know, I don't want to like speak to be expert because we're still figuring this out, but like it seems like the hairy genetic is really like, you know, when there's the scale proliferation around, you know, that primary scale, it's increasing the size of those secondary scales a lot. And I think that's what you can actually see visually, like, you know, kind of from across the room in these homozygous animals. It's like, wow, that's really cool. So, you know, there's a part of like, you know, it adds that texture of the animal. And then, but you know, the eyelashes and crest, I don't know. Yeah. I mean, I wouldn't say that it's anything consistent that we found. But there are certain genetics, obviously, you can pair with this to do some really cool things. And we're still trying to figure out Lily and how that plays in, because I have a couple homozygous lilies. I thought, you know, I had more, but it turns out I have a few, and they do show some interesting scalation. But it's going to take another year to really figure out what that's doing. So.
Yeah, and I think lilies just on their own do so much to not just
Yeah.
the color, the pattern, but also to the scalations that we have
Yeah.
seen with like, the boba lilies, or
Hmm.
even I have a lot of lilies that just on their laterals it looks like it's raised.
Yep.
So
Yeah.
the
It's
scalation.
definitely doing something, and I was surprised that the Lily overpower this genetic. When I found that animal, I was like, okay, this is cool because now I'm going to be pairing that to a really hairy animal and trying to basically blow it up. And I think that's what gets me really excited about this genetic is
Yeah.
it's somewhat uncharted. You know, in combinations with things. So.
Well, that's kind of what David and I like. I mean, David, I kind of talked to you about this a little bit. Is that someone's phone going off, or am I doing something like? Do you hear that? Is that just my computer making that noise?
Oh, you're playing
Um,
a game in the
Just
background.
silence the voices in your head, Nicoletta.
okay. Okay. Anyways, what I was gonna say is that that actually we talked about this a little bit. That I think that the soft skill gene is way less mature as far as what people as far as what people would think, because for so long people are seeing soft skills a certain way and breeding it based off of what they see and feel, that I think there's so much uncharted, untapped area
Yeah.
where soft skills are going to elevate projects so significantly when they're actually bred into it to get these homozygous animals. And you're really going to truly see what it's doing to affect color along across an entire spectrum, what it's going to do when it's stacked with other genetics like the lily white, like xanthic. I mean, that is such an uncharted water that I don't think anybody is really truly even
Yeah, that one could be really cool.
you know because people haven't been pairing it in a way to make that happen as quickly as they can when they have may not have the homozygous animals. They're just going off of a look. I know for me, I'm like 3 years of lilies, I'm like, why am I not seeing anything different? Because my pairings were off,
Yeah,
Yeah.
just
you know?
like I said earlier. I mean, I have these two animals that I could have swore they were homozygous. I could have swore they were
Yeah.
super soft scales.
Yeah.
And if it wasn't for, the work that you guys have done, that now I could go in and look at a macro shot and see the secondary scales and confirm this is a homozygous animal, I would have just bred those animals and said, okay, well,
Yeah.
everything that comes out of here is supposed to be a soft scale,
Yeah.
heterozygous scale. And then
Yeah, and I think
it's
projects
like,
get
it muddies it up, and then people think they have
Yeah.
a head soft scale and they might just have a normal, and then they breed, and
And then they
so
aren't getting the results that they think they should get. And that's what's like, for me, is important to get through to everybody's head, that this isn't about, neither Dan or I did this study to like go after anybody who has been working with the gene in the past. I mean, we're guilty of looking at animals and then saying, oh, it's such and such, based off of believing what someone told us. And that's what got us into this place in the first place, But what is the most exciting is that we actually have a tangible way to identify homozygous animals. And if we start breeding it, by recessive means, which is actually interesting because both, a lot of the people who have currently are defining the gene will tell you, they are constantly telling people, well, it's a soft scale, but it's not until you prove it out. And it's like, in a lily, we don't have to say like, go prove out a lily to see that it's a lily. So we're already telling people to prove it out by recessive means, but we're making it confusing. So there's so many people who are like, I don't understand it, I don't see it. And it's like, we need to take the confusion out of it, and we need to simplify the gene for what it is, because it is not confusing. We have the homozygous, the visual homozygous that can be identified on the iPhone with a loop, with a macro camera, with your whatever you want to do to look at the scales. It's there. And as a breeder, if you feel like you don't want to take the extra step to do that for your consumers, that's not up to me to decide. I mean, that's your personal choice, what you want to do with the information, right? I think it's amazing.
At this point, if you say you have super soft scales and you're not looking at their, the spacing and the secondary scales, and you're just being irresponsible to an extent. But
it slows everybody down.
Yeah, it's exactly, because just like we have all said, we thought we had certain animals that were super soft. That turns out they're not super soft.
Yeah.
But
Another factor,
yeah, go
you
ahead.
know, like hypo, that clean look, like and I think like whenever you get an animal that's called like paper white or hypo, I think that a lot of people are looking at those and kind of correlating it with soft scale, just the look, you know, especially those ones that blew my mind that weren't like, you know, they have like hypo, they're empty back, they, you know, have that paper white and then, but they're not soft scale. You know, they're still really cool. But you know, yeah, you gotta.
Well, if you think of it in terms of like what we've already said is recessive, so like Xanthic is a very easy, tangible one to use because we see that it proves out recessively. How crappy would have that been if dark animals were just deemed het Xanthic because they're dark and they looked like they were dark? And then we started saying, well, some of them are dark, but some of them aren't. And some of them might have this and some of them might have that. So they're now possible het Xanthics. So now we have thousands of possible het Xanthics that people are buying to put together, and no one's making Xanthics. It sucks because it slows everything down. But instead, if we call it a recessive, which is what we're proving it to be in our research as far as what we can see until we're proven wrong, which I would welcome any other studies that people want to do, because that's what we should be doing, is asking questions and studying and finding proof for the things that we're telling people, right? Like, we have to like take into account what all the extra information is doing to slow people down. And I think that Xanthic is a slower project because people are breeding it recessively. But I know for a fact that you, myself, Dan, if people were just selling dark animals as pos het Xanthics because they're dark, I mean, we're 5 years behind, which is what I think has happened with the soft scale. I think we're 5 years behind seeing the true potential of the gene, because we've had opportunity for some of these extra things to come into play and add confusion and possibly just take away from the genetic mutation itself, if that makes sense, you know? And so that's, you know, that's what's hard with the gene. And I will continue working on this gene. This is my, you know, this is my passion project. I know Dan will too. And we're already looking at how it interacts with other genetics. But I think the other big point to drive home to anybody who, you know, is asking these questions is this study itself has caused more people in the community that I've seen ask questions about something than any other information that's been put out there. And that to me is exciting, because I would rather put myself on the line with this information to challenge other breeders, consumers, to start asking questions, look for proof. How are you seeing this? Did you look at who? No one else has ever asked anybody else who's put information about soft scale out if they've looked at the lateral or dorsal scales, or if they've done this or done that. So we're asking questions. We're causing a buzz of education, and that's good. That's exciting. Like, that's what we should be doing when we have some new information come out, right? And that's, if anything else, super exciting to me. I'm like, hey, like, I love the questions. I think we should be asking more questions about genetics and how things are happening, and where's your proof? Do you have information? Can I ask more? You know, where's your phenotypic map that you're mapping these things out? Like, ask questions. It's important.
I mean, it is easy to say like, oh, well, I've been trying to prove this out, or I did prove this out over 5 years, but you know, we got to a point with this that it's like, we got to see something. You know, if there is some color change, like, let's see some pictures. Or I really think a lot of this confusion though is just, it's simple once you kind of take a step back. It's like, you know, these animals that are soft scale looking don't have that tiger pattern in them. So I really hope that, I mean, we're not trying to change people's minds. If they don't want to take the information, it's fine. But I do think if you look at it differently like this, it's going to help projects along. You know, not taking things for granted.
So it's very clear that the research you guys have done is, you know, surrounding the spacing of the scales and the secondary and the primary scales that we see in the homozygous versions. But I know you guys haven't really, and I don't even know how you could go about doing another research paper or anything that would prove that the homozygous version is doing something to the color or or the pattern. But
Yeah.
from you guys' experience, what are you guys seeing in your homozygous animals that is different than heterozygous or normal animals? What are the, aside from, okay, we could all say, okay, you look at it through a microscope and it's a homozygous animals, but what
Yeah.
else are you guys seeing in your homozygous animals that there's not necessarily, there's no research done on it, but just from your experience? You may be wrong, you may
Yeah.
but what do you see?
I mean, out of this, what I thought was really cool was the favorite animals I have in my collection ended up being homozygous, and it's because they were all super unique. Like one, I have Leaf. I've had him for 4 years now, but he's like green, and I'm not saying like he's got olive, but it's a green color to him,
Is
which
that the
is
one that
really
you recently of the
yeah.
dorsal?
Yeah, and you don't see that often in crested geckos, and it might be that this genetic is adding to that. I have another that's like, um, got a bluish color, so I do think that there's a color factor here, but without just like putting it out there and defining the gene as it does this color, we didn't really want to go too far into that because it would take probably a couple more years of looking at these results once we know what these animals are we were working with. But so the color, I think there's something cool. I'm just gonna leave it as I think. But
Yeah.
then with the structure, it's like you add that hairy gene into it, and the one of my animals like has that combination of hairy and it's a homozygous animal, and it's just fuzzy. It's like furry. I call him Furby. And it's really cool because all those secondary scales are spiked up from, I think, the hairy genetic combination there. So he's gonna go to that homozygous lily, and like like I was saying, like
So,
those kind of things like could be really cool.
so do you think this is moving forward in the future? Do you think that this is going to be more of like an enhancer, especially when it comes to structural traits like hairy or boba lilies or, everything else? Do you think it's just going to enhance those these
Yeah,
traits?
I do. I really do. And also I should add like that the one of my females here, um, the best structured animal I have is a homozygous. I don't know what, if it's hand in hand, but it just happens to be that like, she's very impressive animal, which, hopefully we can show some pictures of these as we're kind of talking about it, but
Yeah,
it's
we
like
will.
structure's insane, and so what I'm seeing, I'm liking, and I would love to have see it in Axanthics. I think Lily needs some more development, but
So I
honestly, if I could have every animal be almost like it's like who knows what lines are, and like these awesome lines out there that have unique colors, like there might be more of them that are doing the same thing.
I was gonna add to that too, because Dan and I have gone back and forth on the color stuff for a long time. We also kind of have, in the past gravitated towards different things specific to our soft scale stuff, which has actually been really helpful in our study because we've tried different things within our collections and with these homozygous animals. And I kind of touched on this a little bit yesterday with you, David, but as far as like what we're seeing happen with the color and patterns and things like that in the homozygous animals, whatever it is that we may see, there's proof of what's going on with the actual mechanism of the scales that could potentially cause some of the other things that people have defined it by, this, chromatophore, this, reflection, refraction of light, all of these things that are talked about within the soft scale gene in the past. We actually have a mechanism to support that happening based off of what's going on in the scales. to a,
Yeah.
you know, at a very surface level, because we can't really determine what's going on without getting cross sections and things like that. But what I think is amazing within the homozygous animal is that when we start to take the homozygous and bring it into different projects, we can't, like, I can't say what it's going to do. I can tell you the projects I'm currently working on and the lines I'm currently working on that it is enhancing it in, which for one is tangerine. It's making a huge enhancement in tangerine animals when you have the homozygous soft scale gene within tangerines. I work with tangerines. Reds, it's doing the exact same thing. Some of the, you know, hypo stuff, I don't have as much hypo stuff, but I have introduced pinks into my lines, and I think that pinks may have something to do with soft scale. So I think that I can speak to what it's enhancing, the homozygous animals are enhancing within the projects I like. Not to say that it's not doing things in other colors and stuff like that, but in 5 years from now, I would absolutely bet money that I will have, and Dan will have, some really awesome trait maps to see what the homozygous animals are doing within these different spaces of color and different patterns and things like that, because we'll be able to really isolate the homozygous animals and actually speak to it. But it's 5 years away because, you know, we had to basically dissect and get back to square one to really start to see what it's doing, you know?
Yeah, you have to take a step back to take 2 steps forward.
Right, which is, for me, is exciting because I think it's uncharted territory, but also, like, I feel like I have a means to do it now, you know, especially for me, the lilies, like, that was a huge passion of mine from the beginning, was like, I like this homozygous soft scale animal, and I like lily whites. These are my 2 favorite things. So I got to, like, do this and, like, have this, like, whatever is going to happen. And, you know, so I think everyone's going to start using this gene within their projects if they decide to bring the soft scale gene in specific to what they're doing. And in 5 years from now, I think we'll be able to really have concrete answers as to what soft scale does in all these different spaces, you know?
Yeah, that's awesome. What have you guys? How many soft scale lines do you guys know of? Obviously, there's ACs out there. What other lines are you guys familiar with?
Lines as in like project
where they
based on
like,
it,
Or like, yeah, like, you know, basically breeders who are working with them that don't necessarily go directly back to AC.
well,
Anything
you know, AC has been around forever, so I don't know. You know, that's a hard one to answer, but I mean, I know other breeders that are working with the gene. But I don't.
I mean,
Yeah,
I think, I don't know personally
like
anybody.
what Nicoletta just said, though, like tangerines, you know, lilies. There's several doing that. I only know of one doing Xanthic, working with that. Jerk.
Josh. But Josh, but all of that goes back to AC. So here's my thing, like, all of the different people that I know of personally that I've walked through, you know, some of this stuff with since our conversation and before, people I've bought animals from, like, I don't know of anybody who has their own line of soft scale that isn't somehow traced back to Anthony Caponetto's original soft scale lines. Now, here's what's cool. Some of these people that are tracking it, it's tracked back to way before Anthony Caponetto knew he had it, or had not necessarily knew he had it, but had put it out into the universe that it was a thing. So some of these, you know, AC lines are 12, 15 years old that all of, you know, they're starting to unravel some of this gene for themselves.
Yeah.
So it may,
I guess, you know, it's kind of like how Xanthic came about. You know, there was like 3 or 4 that kind of popped up, but they're all basically, you know, I mean, they're all.
I mean, I think Anthony Caponetto,
and they, you know, the same genetic. But yeah,
like I feel like, you know, they would probably all be compatible with each other. I was trying to get at, like, because we've heard of you know, Tom's SAF. We've heard of, obviously, ACs. Nicoletta, you mentioned Fringe Moors, that they had some, but you said it traces back to AC. but it's definitely, I think theirs is
Yeah, I don't
so
know if he's calling it the SAF anymore. We were just like looking up stuff before. Oh, you were at the spa. Yeah, it's listed as super soft scale now, I think, on Pangea, you know, those animals. So I think, you know, whether it's marketing or lines, you know,
but that's not, but wait a second.
Well, my point in trying to, point in bringing this up is not to say like they're different lines, is to say that
okay.
there's different phenotypes that are
Okay.
that we have in our mind as soft scale. You know, it like the SAF animals from Tom don't look like the soft scales from AC, and the AC
So I mean, I think beautiful animals, right? But like also the tigering, like they're not highly patterned animals, super clean. And then I think that hypo is mixed into a lot of them, which is awesome combination, you know. So I think
it's all the same genetic. 100%.
Yeah, no, definitely.
Yeah, me too.
But you know that unique colors that we see in things, you know, and that's where it's kind of tough, because I think that, you know, some of these things are overcomplicated a little bit rather than breaking things down to the ingredients. You know, the lines, it just sort of, you can have so many lines out there, but when we try to basically say what's doing it, you know, like these unique colors shouldn't then be like, oh, this is its own genetic, you know. It should be like, all right, well, a combination of soft scale and a combination of hypo and the right base color, you can get a, you know, a blue animal or not, but you know what I mean, like that I mean,
but to answer your question too, David, you know, all these soft skills,
I don't remember.
and whatever you are, it's late, I'm old, whatever. So what I was gonna say, because we're all getting tired, is that there are a lot of people who are starting to look at their animals under a microscope or a loop, and this soft scale gene is being shown or showing up in animals that have not been easily replicated by certain people. And that is important to understand, that they didn't even know that this could be a missing link to what they've got going on, and haven't been specifically breeding for this gene to enhance what they have going on. So they've, you know, kind of not known. And I think that that's going to be really cool to see as people kind of prove it out in the next couple of years, that maybe this soft scale gene mutation has helped amplify their projects in a certain direction. Now, again, I am a huge proponent of proving things out in your own collection before calling them something. I don't think it's fair to anybody to, you know, say, oh, Dan and I have recognized the homozygous animal. Now everybody go look under your microscope, and if it has this scale splitting, you know, am I going to tell you I think it's a soft scale? 100%. I'm going to tell you I think it's a homozygous animal. But you need to do the work in your own collection to be able to recognize these patterns, and it should not, and should no longer be a point of marking your animal up for a specific gene based off of looking at under a microscope. I think that's also very important. That everybody, you know, doesn't just like freak out and now everybody has soft scale, which they might, but everyone needs to just take this information, let it absorb, look at their collections, start to work it out in their own projects, see how it's, you know, unwinding. And that gives Dan and I more information too, you know. But if you want to send me a picture of scales and ask me if I think that it's a homozygous animal, I will tell you 100% whether or not I think it is. I know Dan will too. You know, there's just, it's so obvious. It's so obvious. Doesn't matter the color, doesn't matter the pattern. Like, it's there. Right. Very obviously, you know. So
I think the hardest part was like the unwinding the mind of like that look, you know, that soft scale look for me. It's like I'm so used to looking at these animals and thinking their heads, but I mean,
I'm gonna put my 3 girls that are
Yeah.
soft scales, and I'm gonna let people try to guess what they are, and then I'm gonna
Yeah.
feel exactly what they are, so they can
Mhm.
see like, oh wait, maybe you thought this
Yeah.
was soft scale and it's actually not, or whatever. But
Mhm.
so what is there anything else that you guys think is important to address here before we call it a night?
Um,
The only other thing we didn't touch on was one of the other characteristics that was deemed to maybe be seen in some of these animals was the eye color and the ring around the eye.
Yeah,
Um, and then
yeah, I
someone
mean,
did
that
bring
was
that up.
listed like in the first description. That's something to kind of touch on. Is
yeah,
like the change in the descriptions of these animals in the last 3 or 4 years. It's like it started out with several things being, brighter animals, the ring around the eye, the scale spacing of the heads, to now like going from brighter to duller, and then basically, leaving out the eye description. I mean, and it's refining the definition, and that's fine. It's just like
yeah.
what I'm trying to say is like it hasn't been clear. Like
Yeah.
it's been
It's
confusing. Like
it's kind of like when we were first starting to see cappuccinos, everybody was
mhm,
saying, "Oh well, look for that little Y at the base of the tail, and look
yeah,
for a little block of white, and then the rest of the tail be dark."
mhm,
But that's not necessarily something that is exclusive to the cappuccinos, because obviously we have seen many
yeah,
partial pinstripes that will have that Y that don't have the
mhm,
completed pinstripes. We see phantoms that have that little bit of block of white. Maybe it's not as white as
yeah,
cappuccinos, but they do have
mhm,
a darker tail. The phantoms do. So it's
yeah.
hard to, it might be one of those things that
But
initially,
that those markers are there, for the cappuccino. It's like, I, there is something like that
no,
is even
absolutely.
correlated, but like, for this soft scale, it's like, you know,
Yeah, it's all over it's hard to, yeah,
yeah,
I,
it
I
is all.
Well,
hear
the
you.
problem with it is you can also see these traits consistently in other animals. I mean, a lot of phantom animals have that black ring around their eyes. A lot of the new Cal geckos, if they
Yeah,
turn their eyes, you see that black circle, that black ring around the
Yeah,
eyes.
yeah,
The silver eye color, I think, has to do with other different traits and things like that. But is it an actual marker for soft scale and super soft scale to accurately assess it? Absolutely not, in my opinion. But not to say that people aren't seeing these traits in those animals. It's just
mhm,
we go back to the basics of defining the gene in a tangible way for consumers to take it and then replicate it. And it comes back to a very simple way to identify it in the homozygous form, and that is the scale spacing that we're talking about and that we showed in our research. And so all of those other things are sidelined to the actual marker and identifier for the homozygous animal, and
yeah,
like that of a recessive exanthic, and or taking out the ambiguity of all of the extra details. And
mhm,
not to say that they may or may not be there some of the time, but that's not enough to use it to define a heterozygous animal, especially when you're seeing it both in the heterozygous potentially and the homozygous potentially and normal
mhm,
animals. That's just another
yeah.
possible
There has to be a
polygenic.
really strong correlation. And I mean, it's safer to classify something recessive, until you have a good marker. you
Exactly.
know,
Yeah.
um, I think that, moving forward with things that are found, it's like, if you think about it at least that way, um, it makes things a lot simpler.
yeah.
Mhm.
I agree, guys. Well, man, I feel like a lot of people are gonna have to take a listen or two to this podcast. They're not just gonna
Also,
get.
it's super late. I feel like Dan and I tried to muster up all of our energy at the late hours.
Yeah.
Maybe
Hey,
maybe we should.
I'm in the East Coast, so
I know, but you don't
Oh,
have
man, too.
kids.
I'm up here
You
in
don't have
Vermont, man.
oh yeah,
Uh,
that's right, Dan. All right.
yeah.
Well,
kids
guys,
yet, David.
thank you so much. Of course, do
Thank
you have
you.
any
Yeah.
plugs? You
Thank
wanna?
you.
What are your plugs? Where can people find you?
Go for
Instagram
it,
for me.
Instagram.
That's pretty much just on Instagram.
Gecko Harmony.
Yep, Gecko Harmony.
And
And I
Nicoletta.
do shows around the area up here if you're on the East Coast, in the Northeast. Yeah, so.
And
Yeah.
Nicoletta.
And then, yeah, same with me. Instagram. I have a Facebook. I don't really post on it. I have a website as well and some shows. And honestly, the last thing I want to say is like the whole like point of this, like Dan and I are super excited about it. This isn't about pointing fingers at anybody who's done anything incorrectly or anything like that, but instead like we're super excited for what this means for our collections and like our future projects. And neither him or I are unwilling to answer any questions personally. So if anybody wants to reach out to us personally with a specific question or something that, you know, is really like pressing after they watch this or wants more further explanation, you know, we're all about answering questions and welcoming
if
other
if they want to see the paper and your research, they could go to your website, right?
Oh yeah, and that's actually another thing. We're working on a full ebook with all of our information and findings. The goal is to have that done January 1st, 2024. So I'm going on vacation next week, but then when I get back, we're going to full dive into that. But it will have basically all the like the big analyzing stuff that you've been asking, David, like the numbers of the with the study and seeing more pictures of the animals and more, you know, all of this. The summary that you find on my website, we're trying to make that into an ebook with all the nitty gritty details and pictures and all the cool stuff to just have more information. And then also like a full peer reviewed question and answer portion to that too. So people have access to like seeing some of these questions that were asked, our answers to them, and just obviously welcoming other studies and perspectives and things like that into it so that, you know, it's more than just our summary. It's like our actual research, and then we can continue that, you know, going forward when we add new things in, but we want to have a more detailed write-up for everybody as well. So that'll happen early next year.
And I didn't really know what she was getting at when she said ebook the first time she brought it up to me, but
yeah, I don't know how you don't know what an ebook is. Who doesn't know what an ebook is?
I don't know. I do Audible, you know, so but it's just
not
free,
doing
right?
Audible.
I mean, we're not trying to make money, but it's
no,
just like a PDF.
Just download it. No, it's just pretty, Dan. It's you just download it and it's pretty.
Ebook. It sounds like you gotta spend.
No, nobody's gonna have to pay for it.
Yeah,
all right.
Yeah, watch out for her.
Get it out there. You know, it's not profit motivated.
All right, guys. It's about to be midnight here, and I need to go to sleep now. But this was awesome. I'm sure you guys are gonna get a ton of questions, and I'm sure we have already answered so many questions. I know we got a lot of questions.
Yeah, I hope so.
There's been a big buzz about this, but I'm glad we got together and did this. So with that being said, thank you guys so much, and
Thank
we'll see you guys in the next one.
Thanks, David.